Alright, welcome to Chapter 1. We are using the Java Concepts for AP Computer Science book by Kay Horstman, compatible with Java 5 and 6. They're up to Java 7, that's the one you're going to download when you do the JDK. But don't worry, the test is in 5, so they're all backwards compatible, so it'll work. So sort of the way this is going to work is we're going to go through the different sections of the book. For instance, section 1.1, what is programming? I'm just going to sort of blow through the important parts. Chapter 1 is very basic. We're going to go through it kind of quick. But, the important things are sort of these little yellow blocks. A computer must be programmed. The anatomy of a computer, we're going to skip that. You want to know about CPUs and RAM chips, we can talk about later. And then we're going to go on through there, and eventually what we're going to do is we're going to go through this, compiling a simple program part. And what that's going to do is you're going to see when you get your book, it's going to look kind of like this. Brighten that up a little bit. And it's going to be this sort of boundary that's sort of this tannish color, and it's going to have a name up here at the top, helloprinter.java. That's going to be the class name. It also says, public class hello printer. So that's going to be the name you're going to put into BlueJ, and then as your class name, but your project name is going to be where we got it from. So for instance, if this was exercise 1.1, then we would say, exercise or P1_1 as a project name, and then open up and do a new class, helloprinter.java, and then this is the stuff that you're going to type in. And we'll get into that a little more later. So that's what the book and sort of how we're going to go through it, and that's how that's going to work. So we'll close out the camera here. Don't need that on anymore. So first part, section 1.1, what is programming? Well, a program is essentially nothing more than a sequential set of instructions to accomplish a specific task. You want the computer to add two numbers, so you write commands to, so it understands how to add two numbers together. And the basic concepts are the same throughout any programming language, and then we have what's called the syntax. It's kind of the grammar, or the specific writing rules for each language that tell you, how to do it. Usually it's, 1+1 in some sort of format. You're going to store it, you're going to print it. What are you going to do? So like I said, section 1.2, anatomy of a computer, we're going to skip it, not essential stuff right now. We're going to go right into, if you do have your book, I'm going to skip ahead to page 8 and go to section 1.3, translating human readable programs to machine code. So translating what you write in the computer to something a computer actually knows how to use. So your CPU, your central processing unit, is going to execute what's called machine instructions. Each CPU brand, they're all different as to exactly what the codes mean. So you need sort of an interface between you and the computer, depending on the language you're writing. A very popular programming language is C or C++, some version of C. The problem with that, and one thing Java was sort of created to help overcome, is since each CPU is different, you write your program in C and you want to take it onto a computer, you have to compile it on that computer. And then you want to take it to a different computer, you have to go through the whole process and compile it all over again. So Java, sort of the basis of Java is what we call a JVM, the Java Virtual Machine. And you have to pick a virtual machine for each specific type of CPU that you have. So if you have a Sun one or an AMD or an Intel one or a Mac one, whatever, you have to pick the right virtual machine. But once you have the correct virtual machine for that CPU type, any program you write anywhere in Java will work on it. So you can write a program in Java and put it on any kind of computer, a Mac, a Sun server, whatever, provided it already has a Java virtual machine which will run everything for you. So Java, Python, C, these are all considered what we call high-level languages. They're easier to read the instructions, easier to write. Not quite English, as far as sentence structure and actual words, but it's a lot closer. It's a lot easier for you to go back and read. Even easier than what's called like assembler, which is a lower level language, and definitely a lot easier than machine code, although you can program directly into machine code, which is just number digit instructions that mean certain things. But we're going to use a high level language, we're going to use Java, and there's going to be a button that says compile. It runs through what's called a compiler. And that is a bit of programming that takes all of your instructions and converts them into machine code, into the instructions that the CPU knows how to to run. So let's say we wanted to have a variable that contains some numbers. It would tell the computer, we just write in, for instance, if we had, let's say, integer x equals 1, integer y equals 2, system out, which says print to the screen, print x plus y, parentheses, there's a parameter, sort of anything in there is going to happen. The semicolon, it's not a really good semicolon, is an end of instruction, like a period that says this is one giant statement. So in this case, the computer would then print out, obviously print out 3 on the screen. That would be your high-level language, and then your compiler would go in and say, change all of that into instructions the computer can actually run. So instead of int x, it's going to create a space in memory. It's going to store the number 1 as a binary digit. And then when you tell it to print, if that's a command, x and y, it's going to change all of that into go to the memory location for x, take that number, find the memory location for y, take that number out, and then the command for add, run them through the actual hardware in the computer that does adding, and then change that into a set of pixels on the screen that you can read. So high-level languages is a lot shorter, a lot smaller than the massive set of instructions that it gets changed into when it becomes machine code. So section 1.4, the specifics for the Java language. Java was designed to be portable and safe. So portable, like we were saying, in that you can jump it around from computer to computer very easily. And safe because there's a lot of safeguards built in to make it hard for people to access your program. There's a lot of, anytime you go on the internet, you see like update Java or this, Java X runtime environment or even these applets that are running. These are all Java programs running in the background. And it was designed for certain internet applications and designed to be kind of hard to break into. And that it has safeguards for the programmers that it's just harder to write bad stuff that doesn't work or doesn't work as intended, and that there's not a lot of loose ends, hopefully, that other people can start messing with your program. When you run an applet, it should just run as intended. Obviously, there's always ways around it, but that's how it is. One thing that Java isn't is particularly easy to get started in. The commands don't necessarily make a lot of sense if you just look at them, and there's a massive amount of commands that are available. So you're going to get used to using what's called a library, which are pre-written functions, code that the computer already knows how to do. If it already knows how to do it, there's no sense in trying to write it and tell it how to do it yourself. You just get to use the pieces that are already made, math.random, for instance, or generating random numbers, that kind of thing. So we're going to stop here, and your first program, that'll be the next section, the next video.